Hey everybody, it's Mr. Carr again. Today we're going to be talking about 8-1 day 2. Today, like where we left off before, we talked about multiplying with our rational expressions. Today we'll be talking about dividing by with our rational expressions. It's really just one big main concept. Anytime that we're dealing with rational expressions, if we have a over b and c over d, as long as b, c, and d do not equal 0, then a division problem turns into a multiplication problem by just taking our second rational expression and flipping it to its reciprocal. That's it. So we do everything the same as we did yesterday, or the previous video, I should say, as long as we are flipping that reciprocal. Okay. So if we look at this right here, in order for me to divide this out, the step one is flip as a reciprocal multiplication. Space there. Flip as a reciprocal multiplication. I feel like I'm saying that kind of awkwardly, but hopefully get the idea. We're going to take this second fraction and flip it over. So we have 10mk squared over 3c squared d multiplied by 6c squared d squared over 5m to the fifth. So just like we did in the previous lesson, we're going to look for any common factors we can do. So we look vertically and diagonally. So for example, I can take divide by 5 is 5, divide by 5 is 1, divide by 5 is 2, divide by 3 is 1, divide by 3 is 2. I look at my variables. I have a single m here and m to the fifth, so that'll turn into n to the fourth. I have c squared and c squared, and then I have a d and d squared, so that'll turn into d to the first. In my numerator, I have 2, k squared, 2, and d. So if I put those together, I'm going to have 2 times k squared times 2 times d. My denominator, I have 1, 1, and m to the fourth. So I'll just have m to the fourth. To finish off my simplification, I'm going to go ahead and just multiply my numerator together. So I got 2 times 2 is going to give me 4. And I'll put dk squared all over m to the fourth. Okay. Again, it's just like the previous lesson. We just need to turn into a multiplication problem by flipping that reciprocal. So same thing with polynomials. Okay. As we did before with polynomials, we need to make sure that we're going to factor out all of our expressions. Okay. So I'm going to do that as 2 steps here. I'm going to factor everything and I'm going to flip this one. Okay. So I'm going to factor out a 2 from 2d and 6. So I have 2 times d plus 3. My denominator is going to be made up of, let's see, d squared plus d minus 2. That will be d plus 2, d minus 1. We're going to multiply it by, factor this out, d squared plus 3d plus 2 will be d plus 2, d plus 1. And then my denominator will be d plus 3. Okay, so again, I flipped this one, and I did factoring for that section right there. I look for my common factors to make this a little bit simpler. I got d plus 2 and d plus 2 can cancel. D plus 3 and d plus 3 can cancel. And that's it. What's left is going to be 2 and d plus 1. My denominator will just have d minus 1. There's nothing else I can do here besides, like, if I wanted to, I could distribute the 2 out, but it's not necessary. This is fine as is. Okay. One last thing to talk about today is the idea of complex fractions. Complex fractions is just basically saying it's a rational expression. It's a rational expression. Yeah. It's a rational expression in the numerator and denominator. Okay. So that's what, don't like the way I wrote that. Denominator. Okay, so it's a rational expression in the numerator and the denominator, or it's a fraction over a fraction. Okay, so the only thing we're going to do about this one is, because it's a fraction over a fraction, this is a division bar. Okay, a fraction bar is also considered to be division. So that means I could take the top one here. I'm going to rewrite this as a division problem. So x squared over 9x squared minus 4y squared divided by x to the third over 2y minus 3x. So the top half right here is my first fraction, and the bottom half is my second fraction. From here, we're going to treat it just like we did before. So I'm going to factor, I'll factor this part, and I'm going to flip this reciprocal. So this is going to be x squared over, this is a difference of two squares here. So that'll actually be 3x minus 2y and 3x plus 2y. And that's going to be multiplied by 2y minus 3x over x to the third. Okay. From there, we can start canceling out our common terms. Although actually, I'm going to change this up a little bit. Instead of 2y minus 3x, because you notice how it's y minus 3x, but then everything else is x minus y. We're actually going to factor out a -1 from that, so that I can flip that around. So 3x minus 2y. That gives me a common factor with 3x minus 2y, 3x minus 2y. And then x squared will cancel that out to a 1. My numerator is now just going to be a -1. My denominator is going to be x to the first and 3x plus 2y. Okay, and that's it for complex fractions. Again, complex fractions, the only thing about that one is turn into a division problem. So that's it for today. Got a couple problems if you want to try this out. So you want to pause it real quick and give that a shot. There's another one you can try on your own. And if you want to pause it right here and try this one on your own, go for it. Okay, but again, the idea of today is division problems work exactly like multiplication, as long as we do our first step, which is flip the reciprocal. Okay, there it is. Flip it as a reciprocal multiplication problem. Once you do that, we follow the same exact steps as before. And with a complex fraction, that's a fraction over fraction, so it's just a weird way of showing a division problem. All right, that's it for today. Take care, everybody.